In this question, we are given with a vertical circular steel bar of length 3L fixed at both of its ends and is loaded at intermediate sections by forces W and 2W as shown in figure. We have to determine the end reactions if W equal to 1.5 kilonewton. So this is a question of principle of superposition in which the intermediate forces are given 2W and W. The length of each section of the bar is same. This is L length is given. We have to find the end reactions, their reaction at point A and the reaction at point D of this bar. So let us solve this problem. In this numerical, we are given with a steel bar, vertical steel bar, and we have the intermediate forces acting on this steel bar. So at this point, say this is A, this is B, C and D. So at B and C, forces are there. 2W force is there at B, downward direction, and W force is there at point C, that is also in downward direction, and also the value of W is also given 1.5 kilonewton. We have to find out, due to this, these bars is fixed in a rigid supports, and we have to find out the reaction at these supports, right? Due to the downward forces of 2W and W, there will be reaction and at this point as well as at this point. So we have to find out RL. RL means the reaction at the lower rigid supports, and RU, I am writing it RU, the reaction at the upper support, right? So that's why I have written RL, the reaction at lower support, and RU at reaction at upper support. So this we have to find out, right? And now there are two unknowns are there. We have to solve it. Also you have to say that this is a statically indeterminate bar, so that the total deformation in the bar is 0, because it is rigidly fixed between the supports. So that's why the total deformation in the bar will be 0, and the sum of the forces in downward and upward direction should be same for static equilibrium. So there are downward forces are, we have assumed the reaction in this direction at both ends. It may be taken in reverse direction. Whatever the answer will come, if the answer comes negative, then the direction chosen will be the reverse of the direction, right? The actual direction will be the reverse of the chosen direction, right? So we have chosen upward direction RL, because it is these forces are trying to pull it downward, so there will be upward reaction. So we have assumed here the upward direction, and also you can assume downward also, it is your choice. We have assumed upward reaction, right? Here also we suppose that this bar is going downward and this rigid bar will react in upward direction, so there will be a reaction in upward direction. So that's why we have chosen the upward direction. Otherwise you can choose downward also. So RL is chosen upward, and RU is also chosen upward direction. So let us see what will come the answer. And we know that the sum of the downward forces and upward forces should be same, so that the body should be in static equilibrium. So one equation we have already got that RL and RU are upward. So RL plus RU must be equal to W plus 2W. So this is 3W. So one equation we have already obtained. RL plus RU is equal to 3W. Now let us take, we have to break this bar. We have to, because the intermediate sections are there, we have to break this bar, and we have to find out the forces acting in this bar at each section, right? So this is AB, this is BC, and this is CD. Next is CD. Right? So this is A, B, here it is B, C and C, D. So we have divided into 3 sections. This is section 1, section 2, section 3. So this is 1, 2 and 3, and each has a length of L. The length is same of each in 3 sections, right? So there are some points which are common to the two sections, like B is common to 1 and 2, C is common to 2 and 3. So what we can do is we can choose any one of these, RL or RU, and RL or RU, and there will be, and then this D section and A section is not common to anything, any other section. So we can use here that RU must be there. This is RU, and for static equilibrium, RU should also be in downward direction, right? So we have taken RU, starting our question with upper reaction. So RU, 2W. At B, the total force is 2W and RU is already applied. What force should be applied here? What force should be applied here so that sum of the two forces should be equal to 2W? What force should be applied here? The sum of the forces should be 2W in downward direction. In downward direction. So what we can do is we can apply the force 2W minus RU in downward direction. 2W minus RU in downward direction. 2W minus RU in downward direction, so that sum of this and this may become 2W, right? So here I am writing the force on B that should be equal to 2W downward, and we have applied RU in downward direction, RU in downward direction, and 2W minus RU, 2W minus RU also in downward direction, that is also in downward direction. So this RU downward and minus RU downward will cancel out, and you will get the 2W force in downward direction, which is actually the case, that there is 2W force in downward direction. And if it is downward 2W minus RU, there must be upward 2W minus RU so that the body may be in static equilibrium. So there must be 2W minus RU upward force so that the two section may be in static equilibrium, right? And here the force is W. The force is W. So one thing is, we have already got an equation, so we can apply directly. The RL is not common to anything, so we can write here RL in upward direction. RL in upward direction. So for static equilibrium, this RL must be in downward direction also, right? So this force, this 2W minus RU plus RL, this equation we have already obtained, right? This equation can be used. So here we have got the forces. We have got the forces that RU in this direction tensile, this 2W minus RU is compressive, and this RL is also compressive. And what we have to find out? The reactions RU and RL, right? So reactions we have to find out, and we know that compatibility equation, that the sum of the deformation in total bar should be equal to 0. So we can utilize this concept that the delta L deformation in total bar should be equal to principle of superposition, that delta L1 plus delta L2 plus delta L3, and that should be equal to 0, because the body is fixed in the supports and there will be no deformation if there is no yielding of the supports, right? So delta L must be equal to, so delta, and we can use this equation, delta L1 plus delta L2 plus delta L3. So delta L1, force in this RU multiplied length is same, L, upon area is also same, and E is also same. So RUL by AE, A and E are same for all the sections, plus delta L2, this we have this force, so but this is compressive, so that's why we are taking negative here, because this force is compressive, 2W minus RU. So take it 2W minus RU L upon AE, and then RL is also compressive, so take minus RL, length is same, AE and that should be equal to 0 because there is no deformation, total deformation in the bar. So from here AE will merge in 0, L will also cannot be equal to 0, so that's L also will be removed. So you will get, what you will get is, you will get RU minus 2W plus RU minus RL equal to 0. This thing you will get. And on further solving, what you will get is 2RU minus RL must be equal to 2W. This is equation number 2. So this was the first equation. This was the first equation, that RU plus RL must be equal to 3W. This was the first equation, and this is our second equation. Two unknowns are there, RU and RL, and that can be solved very easily. So if we add up these things, if we add, so adding 1 and 2, we will get, what we will get is 3RU will be equal to 5W, or RU will be equal to 5 by 3W. And what is W? This is 1.5 kilonewton, so that will be equal to 1.5. So 5 by 3 multiplied by 1.5, so that will come out to be 3, 5, 25, so it will come out to be 2.5 kilonewton. 2.5 kilonewton. So one answer we have got, that the reaction at upper end, reaction at upper support is 2.5 kilonewton. So this is our one answer. 5 by 3W or 2.5 kilonewton, right? And we can also find out the reaction at lower support, RL. What we can do is, we can use this formula also. RU is known to us, that is 5 by 3W. So RL plus RU is 5 by 3W, 5 by 3W, and that should be equal to 3W. So from here you can find out, you will get minus 5 by 3 here, 9 minus 5 by 3, 4 by 3W. So RL you will get as 4 by 3W, and that should be equal to 4 by 3 multiplied by 1.5, that will be equal to 2 kilonewton. So RL is 2 kilonewton. So that is our another answer. So we have got both the reactions at lower support and as well as upper support equal to 2 kilonewton at lower, and upper end it is 2.5 kilonewton, and both are positive. It shows that the direction selected by us was correct, that we have selected both the direction and upward. So RU is also upward, as well as RL is also upward. It means this is positive, means it is in the direction of the selected direction, chosen direction.